guys, today I am going to take subject physics for the topic light refraction of light. Last class I released a video for light reflection and refraction of light also another important topic in the light lesson. Okay, so I want to give some now I would like to give some illustration so that you will understand about refraction of light. Now I am keeping the pen inside the glass, so filled with water also. Now you can see that the pen actually taking a bend here. You'll see that some bend will be there. Okay, isn't it? So why that bend is appearing is because light is traveling from air media, which is rarer media, and water is denser media. So when rarer media to denser media, when light travels, then it starts to bend. So that bending up of light, when the light travels from one media, air media, to another media, that is water, then light gets bent. This phenomenon only we call it as a refraction of light. One more example also. I am taking about the lemon size. You can see that what is the size of this lemon and all. So now I am putting this lemon inside the water. Now you can see that lemon size is enlarged. So I'll just show you. Now inside how much is bigger appearing. Now I'm taking closer, it is very smaller size will be there. But inside the water, it appears as such a bigger size and all. Okay, like that I'll show you my finger also. Now it's very small size is there. After I introduce, you would have seen that they are bigger size and all. So these all are phenomena are happening because of the refraction of light. Okay, now I would like to show the experiments for refraction of light. Now what you have to do is you have to take the glass slab A, B, C, D. So that is nothing but rectangular type only. It is full made up of with a glass. So it is a solid material like a cuboid. Now what happened? You are passing the light in a slanting manner, obliquely you are passing. So when you are passing that light, here E and F, you should fix some pin actually. That pin you have to fix it here on the table. Then, so after that light travels here, then that starts to bend. You can see that actually the glass slab, if you observe, the light, we already know that light always travels in a straight line. But because the light is traveling from air media to glass media, densities variations are coming, so it starts to bend. Again, after glass media, again going to that air, so it takes again another bending also happening here. So what I mentioned here, I is incident ray, then here refracted ray, so I1, R1 I mentioned. Then from denser media to rarer media also again the light is traveling, so I2 and R2. So here exactly what is happening, let us see here. So when the light travels from rarer media to denser media, then we have to draw the normal ray also. Okay, so in that normal ray, this is actually, it is closer to that will be there, incident ray. After refraction, after refracted rays are closer to normal ray will be there. But after the light comes from denser media to rarer media, if you look at it, then these refracted rays are away from the normal will be there. So these things you have to observe in this experiment. So now I want to say two refraction laws. Okay, now I want to say about law of refraction. So what is the law of refraction actually? So if you look at it, incident ray, then whatever the refracted ray comes over here, then the normal ray whatever I have drawn, all you can see that only in the same plane, isn't it? Only one plane only it is there. Okay, then what is the second law says? Second law says that sin I by sin R, so that value will come as constant. I means incident ray. So here let us consider the angle as I1. So if the angle is I1, then we have to write it as sin I. Trigonometry already we have released that videos also. So sin I you have to write there. That value how much is coming for that particular angle sin value. Then after refraction, sin R also both you divide. So both you divide, then that value will always comes as constant. This is we call it as refractive index. Also this is actually we call it as Snell's law also. So these two laws are happening in the case of the refraction. Now let us see refractive index n to 1 I written. What is that n to 1 means? When the light travels from one media, that means air media, then the light always that is also going in the solid media also, that means glass media also it is going. That media we considered as 2. This is medium 1, this is medium 2. So now how do we can write that refractive index? How we can find out refractive index equal to, that means second medium to first medium, so 2 1 I written. So that is equal to speed of light in the medium 1. Medium 1 is air medium divided by speed of light in medium 2. Medium 2 is glass material. So we already know that speed of light in air media vacuum is 3 into 10 to the power of 8 meter per second. And in the air also it comes as refractive index as same value only. It's not much variable. So negligibly same value only, 3 into 10 to the power of 8 meter per second only we can take when the speed of light in air also. But when it travels in the other media, like water is there, suppose water we have taken and then the light is traveling. Why I just showed in the starting experiment only, light gets bent actually pen after keeping. Why that is bending means air density is refractive index is 1, then refractive index for water. Okay, refractive index of water is 1.33. So because 1.33 is there, but air refractive index is 1, because that variation in refractive index is there, because of the density variation, that is why we just get the bending up of the light. Okay, then if you take about crown glass, then its refractive index is 1.52. Then if you take about diamond also all are transparent material. See, whatever we are taking, all should be transparent material. If there is no transparent, then light never travels at all. Opaque material we should not take. Now diamond I just said about 2.42. Now I would like to say about two type of lenses, spherical lenses. Because lenses, if you take plain glass, okay, there is normal glasses, no, we cannot see any much variation. If you just take about spherical glasses, then we can see that some variations will happen for the images and other things also. Now let us take two type of spherical lenses. One we call it as a concave lens, that is actually diverging. Then another lens we call it as a convex lens, that is actually converging. So this is diverging and another one is converging. So if you take about concave lens, that always produce images virtual, erect and diminished only. Okay, because it is making very diminished images and virtual images, we can use it only for certain uses only. Where we can use concave lenses and all. Concave lens, one is they are using for myopia, that is short-sightedness. Then apart from this, it is because it is making a diverging, so we can use it for a projector light, as a flashlight also we can use it. Then it is also used in the case of the binoculars also they are using. Okay, next let us see about convex lens. Convex lens is making real and inverted images, and it is converging also. So these type of lenses will produce about a highly magnification and all. So this is used especially in the microscope. It is also used in the telescope also. Then apart from that, it is also used for the hypermetropy. Hypermetropy is nothing but long-sightedness. Now I am just showing whatever the lens is, actually this is actually convex lens. Why I am saying convex lens? So what is actually convex lens contain? See, middle portion, if you just look at it, it is bulged one. If you look at the edges, it is pointed sides are there. So that means here it is bulged one, then at the edges it is going down like a pointed size. So that is what we call it as a convex lens. Now if I take that convex lens, you can see that pen size is how much is there. Now after just showing, you would have seen that bigger size and all. Why that is happening? Because it is diverging. So that is a bigger size it is happening there. Okay, next I want to show about okay, my own spectacles only. It is actually concave lens actually. So concave lens mainly they are using for short-sightedness. So here what is happening means, so in the center if you look at it, is very thin are there. Then if you look at the edges, it is very thick also there, thin and thick here. But in the case of the convex lens, middle it is very thick, then at the edges it is very thin and all. Now if I just show that concave lenses, you can see that pen size actually this much is there. So after I'm putting, you can see that size is reduced actually. Why that is reduced means because it is converging. So these are the difference. Now I would also show about some of the ray diagrams. Now I want to say about ray diagram for convex lenses. Already I said what is a concave lens. So this is a method you have to draw for the convex lens and all. That is thicker at the middle, then thin at the edges and all. Now if you take the object at infinity, infinity means there is already I said f1 we should take. F1 is nothing but principal focus. Then 2f1 I return. So 2f1 is nothing but center of curvature. So if you center of curvature, if you take this lens itself is a part of the circle only. So from here it is like a radius type only. We can draw the circle, isn't it? Like this I can draw. So that radius, and this is half of that value of the radius only. We call this as a principal focus. So how much value you have taken, that say that 2f1 will be double times will be there. So here I have taken 2 centimeter. So here also 2 centimeters. So 2f1 will be center of curvature c1 I return. So that will be 4. Here 2 centimeters. Here comes as 4 centimeter. Now I am taking the object at infinity. Infinity means it is beyond the 2f1 is there. So if you take any object, we can take either tree or we can take any windows, other things also. So once that parallel beam of light comes over there, so here I have drawn one of the principal axis also. Principal axis is nothing but imaginary line which is perpendicular to the optic center of the lens actually. Optic center we mention it as O. Now parallel beam light comes over here. Now what will happen? After falling on that lenses, now air media to glass media it comes. So it starts to bend. So after bend, that focus at F2. F2 is nothing but principal focus. So because light can travel in glass media from one side to another side also. So we won't get here reflection, we will get only refraction only. So after refraction means nothing but bending of the light. So parallel beam like this straight line going, again taking bend and forms at F2. So now what is the nature of the image? Image forms at F2, then it is very point sized or sometimes highly diminished also we can say, and we are able to capture that image on the screen. So it is real as well as inverted images also. Next let us take object beyond 2f1. That means after beyond 2f1 means 2f1 somewhat beyond that we are taking object AB I am taking here. AB maybe candle also we can take. Now the candle light after just falling on that lens, what will happen? Because convex lens having a converging property. So after the light falls over here, because of the refraction phenomenon, that starts to bend and focus, it has to go through F2 only. So here also F2 it went, here also F. Then another line should pass through optic center. So optic center line where these both lines are meeting, there the images are formed. So here also you should take certain rules and all. Here how much 2 centimeter I have taken. So here also 2 centimeter. From here to here also 2 centimeter. Then here to here also 2 centimeter. So if you draw and practice this diagram in your paper and all, it will come correctly. So after that images I am getting here. So where I am getting that images, okay, after the lens actually. So image between F2 and 2F2. So F2 and 2F2 means after the lens we mentioned as F2 and 2F2. Before the lens we are mentioning it as F1 and 2F1. So between F2 and 2F2 it is forming that images. That what that image size I am getting, see compare, you can see the length height of the object also. So it is lesser there, so it is diminished size as well as we are able to capture on the screen. So it is a real one, and you can see that object is like that is there, but we are getting in a ultra type and all. So that is why we call this as inverted. That means principal axis down we are getting. So it is inverted ultra type, you can see it also. So next let us see about when you keep the object at 2f1, what will happen. Now you take the lens and this is the object here. So parallel beam of light goes there, then goes to f2, then here you have to pass through O, optic center. Then where both are meeting you have to find out. So after just meeting you will get at 2f2 only image. So what is the nature of the image actually? It is same size as the object, image size, as well as we are getting real as well as inverted also. Now let us see about when the object between f1 and 2f1. So between f1 and 2f1 I am taking the object. Now after taking that object, then the parallel beam of light goes there, then goes through f2 also, then here through optic center. So after that meeting, you will get that image is enlarged. Where we are getting that image? After 2f2. So it is also real as well as inverted. Then let us take the object at f1. F1 when you take, what will happen? So after that f1 if you take, then after the light passes over here, it passes through f2. Another one you pass through optic center. Then both parallel beam of light only will go. You will not get the images immediately. That means at infinity only you will get the images. So because it is going infinity, so the size of the image will become highly enlarged as well as real and inverted also. Then let us also see about when we take object between f1 and optic center in the convex lens. So convex lens I have taken. Now I am keeping the object between f1 and optic center O. Now after keeping this light, after coming here, it just goes to f2. Then other light comes through optic center, it has to go. So it will not meet here because it is getting diverged. Once you take between this, that gets diverged, but that will meet only here. That means in front of the lens itself it is coming. Because in front of the lens itself is coming, we are unable to capture on the screen. So this type of image we call it as a virtual as well as erect image we are getting. Because it is also erect, here also it is erect is there. But the size of the object is enlarged one. Okay, next let us take about concave lens also. Now concave lens is nothing but thin at the middle, then thick at the edge and all. So I have drawn this. Now I am taking the object at infinity. So parallel beam of light going there. Because it is a diverging lens, so the light rays gets diverged, but it appears to come from certain focal length, principal focus f1. So if you just extend that line, it will meet at f1. So that f1, it is coming in front of the lens itself. So that is why already I said, in the case of the concave lens, it is always forming a virtual and direct only. But if you keep at infinity, that object size is highly diminished, or point size only will get, only point size like this will get. Now suppose if you take that object between infinity and optic center O, anywhere you are taking between optic center and then beyond 2f1 or at 2f1 or f1, wherever you take it also, I just consider it as f1 and 2f1. Now if I keep that object AB, then after coming over here, it is getting diverged, but through optic center also you draw the line, so you will get that both will meet this point actually. So here the image you will get, that image where you are getting between optic center and f1, but size is, it is virtual as well as erect also, because it is a size also you can see diminished size only. So any concave lens you will you will get a diminished size only images and all. Next important thing is sign convention for the mirror as well as lens. For doing any calculation, this formulas and all, your sign convention you have to follow it up. So first I want to say for mirrors, 1 by f, f is nothing but focal length. Okay, focal length is equal to 1 by v plus 1 by u is the formula. So what is meant by u? U is nothing but the distance between the lens optic center O and object where you have taken this object. Suppose in this cases O and whatever the AB I written here, this and this distance we call it as u and all. So object distance we call it as u. Then what is meant by v? V is nothing but optic center to where we are getting that image, that distance we call it as v and r. So 1 by f equal to 1 by v plus 1 by u will come for the case of mirror. But if we take about lenses, 1 by f equal to 1 by v minus 1 by u and r. Okay, then if you look at the focal length for mirror as well as lens also, focal length always will come as r divided by 2. So radius of curvature how much are there, that you divide by 2, then you will get focal length. In the case of lens also same only. But in the case of the magnification, if you look at it for the mirror, so h1 is nothing but images, height of the images for the image actually. So here h is nothing but height of the object, height of the image, height of the object. So that is equal to minus v by u formula. Okay, then in the case of the lens, magnification m equal to h dash divided by h. That means this is height of the image, this is height of the object, that is equal to V by U we have to take. Next, power only will come for the lens only. So for power of the lens is written by the formula 1 divided by F. F is principal focal length actually. Focal length you should convert into meter. In case they are given centimeter, we know how to convert all this and all. So convert into meter and then divide. So 1 by F in meter, that gives about power of the lens. Power of the lens unit is diopter. So then power of the concave lens will always come as negative only. Power of the convex lens will always comes as positive. So already refraction of light in the case of the concave as well as convex lens I just explained also. So you would have understood how the ray diagram comes, so what are the sign conventions you have to use for calculation purpose and all. So follow all this and all, then it will be very much useful. Okay, thanking you guys because you observed for such a time, and share as much as possible. So I want to be videos should be useful for every students also, whether they are studying in other classes also. Once they are coming to 10th standard, it will be very useful. So I hope you will all do. Okay, thanking you.